Cascal have created and constructed the most advanced facade testing facility, available for commercial use in Southeast Asia. Having been involved in facade industry for quite some time, Cascal understand the need for an efficient, flexible, and modern approach and facility to carry out testing. The testing chamber has been designed to accommodate any shape or form of facade sample up to 23 meters high and 16 meters wide. An indoor chamber is also made available for Surroet method of testing that can accommodate samples of 10 meters high by 10 meters wide. The chamber has been designed to take a maximum pressure of 10 kilopascals. Whilst designed to undertake the testing of very large facade samples, we are also able to carry out much smaller requirements including windows and door systems, all at very competitive service rates. The chamber has been designed for ease of installation with overhead cranes and electric suspended platforms constantly available for sample installation and inspection. The testing laboratory has a fully computerized system for controlling instrumentation and data acquisition that includes result analysis against known standards. The system incorporates LabVIEW software that provides real-time review of the test characteristics resulting in extremely accurate results. Cascal facility has also considered the safety and comfort of visitors attending or installing the testing of the facade. CCTVs are in place for viewing the test within comfortable lounge where internet access is available and a refreshment area. Cascal can provide transportation during the testing period, hotel arrangements, and airport pickup and drop-off are all part of the service. Cascal, we only aim for the best service for our customers' satisfaction.
Okay, good afternoon everyone. So for me, my topic is about the significance of testing. And probably we heard already from Mr. Simon Chin and Mr. Paul and Kevin about the types of the buildings that we are dealing with currently. So my presentation will be composed of the introduction of the facade testing, some test standards, which I will only mention those that Mr. Simon have not mentioned well, and some testing procedures. I will show some videos as well, and I will give also some background about the ISO 17025, which is the governing accreditation for the laboratory. And then I added some few topics about PMU for exploratory testing, PMU as VMU as well, and PMU as venue for MS development or development of method of installations prior to the actual work. Okay, facade testing, why it is significant. As we have seen from Kevin and Paul, you can see the buildings now are becoming more complicated. And this is where now PMU testing is very demanding. And not only like 1 or 2 PMU testing for one project. I think in one building, for the buildings that they have shown, probably minimum of 3 to represent all the typical and the critical areas of the facade. So due to this growth and economic growth and construction development, the trend now for testing is to verify all these factory-built products or curtain wall systems, which we have to verify first in the laboratory test prior to installation on site. And one of the significant things in testing is also to be able to develop the design, not only just to test it, but sometimes most of the tests, it fails in the first time. And after that, they were able to develop the systems, their systems, and at the same time, they were able to conclude the final design of the facade. So I will just mention some of the parts of the test standards. And the basic standards that we normally do is for air infiltration test, which is testing for the air leakage across the specimen. Water penetration test is to also the resistance of, to test the resistance of the facade for water penetration, either by static air pressure, cyclic pressure, or dynamic pressure. And importantly, also the structural test, which ensures the structural stability of the building or the facade on the building. And at the same time, it continues to the proof load testing, which confirms the safety of the secondary part of the building, which is the facade. And apart from that 4 basic tests, there are some other testings also that are optional. So we have water test by cyclic pressure, water penetration test by dynamic pressure by the American standards, inter-story displacement test, or we call for seismic test, BMU restraint test, which is the building maintenance unit restraint testing for the components that we put in the facade for BMU fixings. Seal degradation test also is one of the important tests where we perform some seal degradation or simulation of degraded seals or broken seals and make sure that the facade or the curtain wall is still performing after some time. Then another optional testings for some projects are now becoming also demanding is the thermal cycling test, acoustic test, and fire resistant test. So below you can see all the common standards that being used in the testing, like the AMA, ASTM, the ISO method of testing, British standard, Japanese standards, and Australian, New Zealand standards. So just mentioning this, for the air leakage test, ASTM 283, water test, ASTM 330. Structural test is ASTM E330, and then for the water test, ASTM 331. This is the common standards that we are using in the test. This is the standard. This is the reference for how we are going to do the test. And we have also the ASTM E547, which is the cyclic pressure test, which is equivalent to the cyclic pressure test of the Australian standard. And we have the, for the acoustic test, we have ASTM E90. For fire, we have E19. I will not go through this much because I think there's somebody, next speaker, that will discuss this in more detail. And then also we have all these tests that are for acoustic, thermal testing, and fire testing. So for Cascal, we don't have this type of testing yet, but maybe in the future we are aiming also to have all these tests to complete the requirements of our customer. So we have also Australian standards, and the most common is the ASNZ 4284. We have also the BS standard, British standard. And those I mentioned earlier are the standards, the method of testing. And these specifications that I'm showing now are the specifications, standard specification, which gives the criteria in order criteria for the performance of the facade. It will give the minimum and the maximum performance criteria for the testing. Apart from some of the most of the consultants, they have their specific performance requirement, but if there's none, the test must be referred to these standards. So just to give you some brief information on how we do the air leakage test. So basically, for a chamber test, we have to separate the air leakage of the chamber. And mostly for the curtain wall, the chamber is huge. So there will be a potential air leakage around the chamber as well, apart from the specimen. So what we do is we introduce some tapes or plastic sheets to cover the whole specimen. And then after that, we remove it and we subtract the air leakage from the total leakage. Then we will get the net air leakage across the specimen. So for water penetration test, so we need some spray racks or some spray booth to spray the water evenly into the specimen. And then we apply the pressure. For the American standard, we apply the pressure inside the chamber, which we simulate the positive pressure outside as a negative pressure applied inside the chamber. For the Cyroweight type of testing, which is the Australian way of testing, we have to apply the pressure into the external face of the facade. That's why we have the indoor chamber to cater those requirements. So this is the dynamic testing from the American standard, where we use the aircraft propeller, or some now they are using fans to simulate a dynamic wind into the facade while the water is sprayed into the face of the curtain wall or the specimen, and the client or the contractors are inside observing the leakage, the water leak or any water leakage inside the building. For the structural test, we call it wind pressure test. We are simulating the pressure outside the building by applying a static pressure either inside or outside face of the specimen. And as you can see, we in the monitor you can see the pressure, the deflections, and even the sequence of testing for structural test. Okay, I will show you some video. So for structural testing, there's some. It can be a static pressure, or it can be a cyclic pressure. Like for example, for Japanese standard, they have the structural with the cyclic pressure. And I would like to go back to show you some video of the dynamic test. First is the video from outside. Yeah, we are still using the 4-meter propeller aircraft engine, which is the standard for the American standard. And then if you are inside, so this is another propeller that we have, the smaller one. Where's the inside? Okay. So this is what you get from inside of the building or the chamber, where you can see how the dynamic pressure hitting the water and try to penetrate the specimen. So one way that you can appreciate the dynamic pressure is to see these transducers. You can see how it affects the glass. You can see the dynamic movement of the glass due to the wind pressure outside. Okay, we go to the building movement testing, which is now also very in demand, even in Thailand. So most of the tests that we do, they also include the building movement test. So it can be a vertical movement testing, a horizontal movement testing, and sometimes an in and out simulation of the building movement. All these movements are expected from the building due to the seismic or the wind induced pressure. I will show some video of this seismic testing. So I used one of our Japanese tests, which is very exaggerated. Then you can really appreciate the racking of the panels. And then from inside, you will also see how the panel behaves due to the movement of the building. So for the curtain wall is very curtain wall system, it's very effective in accommodating these movements. Okay. So another testing that normally done for a facade is the BMU restraint testing. This is to simulate on how the fixtures of the BMU parts is put in the facade and loaded according to the requirements. These loadings normally come from BMU or building maintenance equipments, or some gondola or some Spider-Man system, or some used for the replacement of glass. This is the thermal cycling testing. So I will not touch this one in detail, but this is one of the tests also that for some areas of the world that have a huge effect of thermal cyclic. Acoustic testing also is very common now. And this is to test for the sound transmission across the specimen. We have also the fire testing, which is also employed by some of the projects in order to make sure that the curtain wall system will not cause any continuous fire on the building or in the facade. For the ISO 17025, for a laboratory, this is very important. This is the guide of a laboratory, which is in conjunction to the international standards. So we have the ILAC as the main accreditation body, and where all the laboratories will be under this international authority for inspection. And as you can see below are the common accrediting body In Thailand, we call it the NSC. In Hong Kong, we have the HOCLAS. In Singapore, SingClass, and then we have the NATA in Australia. So all these bodies are under the ILAC. And to give you more details, so from the international accreditation, we have also the APLAC, where all this Southeast Asian accrediting body is under. APLAC is the Asia Pacific Laboratory Accreditation. And our laboratory in Thailand is under NAC and is also just got the certificate for the ISO 17025 2017 version. Okay, one of the advantage of PMU testing also is the exploratory testing. Some of the customers that we have, they come to us and do some exploratory testing, or even during the actual testing, if they have some issues in their samples, they continue to explore their systems and they try to do some more testing. Then after that, they will do the final testing. So PMU is also a venue to develop the system or the design of the facade system. And we are very flexible to accommodate the requirements of our customer in order for them to be able to achieve the goal of passing the test. So PMU as VMU. So apart from VMU, as what Kevin and Paul shown earlier, PMU also is sometimes used as the second VMU, because during the VMU, by that time they are just simulating the shape of the facade. They by that time they are not able to get the actual profiles that they are going to use for the curtain wall yet. But on the PMU, most of the time this is already utilizing the final and actual aluminum profiles for the curtain wall, even the glass, even the claddings, like what you are seeing now. This is a PMU, but partly a VMU as well. And some architects came earlier in order to criticize or to develop more about the aesthetic aspects of their facade. So this is also another project that is also required to be the VMU, employing all the colors, the glass, and the actual profiles of the curtain wall. This is another one project in the Philippines, and also a second VMU for this curtain wall system. And PMU also, I can also say that it's a venue to develop your method statement or method of construction or installation of the facade. PMU is most of the time is the first time that you are going to produce this curtain wall and install. So we also allow our customers to exercise or develop the installation method. So then before the actual works, they can establish their procedures on how to install the curtain wall as per design. Even the equipments and the tools, they can also do the trial for the method that they're going to use for lifting, for surveying, and for measurement. And they can also use their nominated subcontractor to be trained during the installation of the PMU, so that all the important part of installation, the critical areas of sealing, all these are being recorded and being observed by the supervisors or even the installer themselves. Okay, and I think that's all for us. And thank you very much for your time.